Hello friends, welcome to Learner's Planet. Friends, this is our second session for time, speed and distance. Friends, in our previous session we have already discussed the basics of the topic and I'm sure you might have revised that particular session, so you'll feel more comfortable in this session. So in this session we are going to take some simple applications and problems of time, speed and distance. Now let's begin with the first question. Let's take this simple problem. A car moves at a speed of 80 km per hour. What is the speed of the car in meters per second? A very simple problem of unit conversion. Here the unit is kilometer per hour and we have to convert it to meter per second. Okay, so 80 kilometer per hour is equal to 80 into we can convert kilometer to meter by multiplying 1000. Similarly, hours to minute is 60 and minutes to second further 60. Okay. So it is 800 by 36, or we can say 200 by 9 meters per second. Okay. So it is 22 2 by 9. Friends, if you can memorize, if you wish to convert kilometer per hour to meter per second, directly you can multiply by 5 by 18. 5 by 18 is nothing but this 1000 by 60 into 60, that is 1000 by 3600. If it is simplified, it will give 5 by 18. Okay. Now let's see this question. An athlete runs 200 meters race in 24 seconds. His speed is. Friends, what is speed? Speed is equal to distance by time. Okay, now what is the distance over here? It's 200 meters. And what is the time over here? 24 seconds. Since all the options are in kilometer per hour, we need to convert this meter to kilometer and this second to hours. Okay, so it is in meter per second. Now if we wish to convert this meter to kilometer, we have to divide by 1000. And if we wish to convert this second to hours, we have to divide by 3600. Okay. So it is 5 6 are 30, that is 30 kilometer per hour. Okay. I hope you are clear. Now in this question, we have to find which of the following trains is the fastest. Friends, these are the speeds of a particular, maybe 3 trains over here, and we have to find out which of them is the fastest. Now friends, if we wish to make any sort of comparison of speeds, all of them must be in the same unit. Here it is meter per second, meter per minute and kilometer per hour. So first of all, let's convert all of them to same unit. Okay, so let it be meter per second. We convert 1500 meter per minute to meter per second. So it will be 1500, it's meter. And if I wish to convert minute to seconds, I have to multiply by 60. Okay, so it is 125 by 6, that is 25 meter per second. So speed of this and this is the same. Okay, now since only one of the option is correct, that means I'm sure this must also be the same, since 2 options cannot be correct, so we need not check it. Okay, just for the sake of clarity, I'm just solving it over here. Kilometer per hour is 90 into 1000 by 3600 meter per second. Okay, 0 over here, 9 4, it's 25. So it is also 25 meter per second. Since more than one option cannot be correct, so none of them is the fastest. All of them are having the same speed. Okay, it's just a game of conversion of units. I hope you are clear. A person crosses a 600-meter long street in 5 minutes. What is his speed in kilometer per hour? Okay, let's write over here. Speed is equal to distance over time. So speed is equal to distance is 600 meters and time is 5 minutes. Now we wish the answer to be in kilometer per hour. So to convert meter to kilometer, we have to divide by 1000. And to convert meter to hour, minute to hour, we need to divide by 60. Now it is kilometer per hour. Okay. That means it is 36 by 5. That means 7.2 kilometer per hour. Okay. Now in this question, a man walking at the rate of 5 kilometer per hour crosses a bridge in 15 minutes. We have to find out the length of the bridge. Now, length of the bridge is nothing but the distance covered by this person. Now, if speed is equal to distance by time. Okay, now speed over here is kilometer per hour and we want the answer to be in meters. So let's convert this kilometer to meters. So it is 1000 and per hours will be converting it to minute since the time over here has been given in minutes. So it is 60. Okay, is equal to distance we have to find out and time is 15 minutes. Okay, so what is the distance he has covered? That is 250 into 5, that is 1250 meters. Okay, and the distance which is covered up was the length of the bridge, so the length of the bridge is 1250 meters. I hope you are clear. Now further, a simple question. In this particular question we have to calculate the distance covered up. Okay, a car is running at a speed of 108 km per hour. What distance will it cover in 15 seconds? First of all, here time is in seconds and the options are in meters. So let's convert this 108 to from kilometer per hour to meter per second by multiplying by 5 by 18. Okay, so it is 108 into 5 by 18 meters per second. Okay. So it is 6 into 5, 30 meters per second. Now this is the speed, this is the time. We can calculate the distance. So it is distance is equal to time into speed. So it is 15 into 30, that is 450 meters. Okay. I hope you are getting my point. Now let's say this question. One of the two buses completes a journey of 300 kilometers in 7.5 hours and other a journey of 450 kilometers in 9 hours. What is the ratio of their average speed? Friends, let's calculate the speed of this and this. So it is 300 by 7.5. That is the speed of first bus by speed of second bus is 450 by 9. Okay, so S1 by S2 is equal to 9 into 300 by 7.5 into 450. Okay, so it is 4:5. Okay, I'm sure you are clear. Now let's say this question. How long will a boy take to run around a square field of side 35 meters if he runs at the rate of 9 km per hour? Now let's assume this is the square field and the length of this square field is 35 meters. Since it is a square field, all the sides of this field will be same. So this is 35, 35, 35 and 35. That means the total length which he has to cover up is 35 into 4, that is 140 meters. Now what time is? Time is equal to distance by speed. Now distance is 140 meter and we have to calculate the speed. Friends, the distance over here is given in meters, and speed is in kilometer per hour. So let's convert this kilometer per hour to meter per second. So if we multiply the speed by 5 by 18, we'll be getting the speed in meters per second. So it's 5 by 2 meter per second. Okay, just write over here 5 by 2 meters per second. Okay, so it's 28 into 2, 56 seconds this boy will take to run around this field. Okay, I hope you are clear. Now further, here also we have to compare the speeds of two vehicles, that is this truck and a bus. Now this truck is covering a distance of 550 meters in 1 minute, and the bus is covering a distance of 33 kilometers in 45 minutes. We have to compare their speeds. Okay. Now, friends, here the length which is covered up is in meters, here it is in kilometers. So if you wish to make this comparison, both the length should be in same unit. So let's convert this kilometers to meters. So first of all, speed of truck is 550 meters per minute, and speed of bus is 33,000 meters in 45 minutes. Since 1 kilometer is 1000 meters. Okay. Since both the timings given over here are in minutes, so doesn't matter whether we keep it like this or we convert it into seconds. Okay, it won't affect the final answer. So S1 by S2 is equal to 550 by 33,000 into 45. Okay. Okay. So it is 3:4. Okay, I hope you are clear. Friends, I'm sure you are having your paper and pen with you and you are solving the problems with me. So just pause the session, try the problem on your own, and then match your answer and solution with mine. Okay, so let's say this question. A certain distance is covered by a cyclist at a certain speed. If a jogger covers half the distance in double the time, the ratio of speed of the jogger to that of the cyclist is what? Now friends, what is speed? Speed is equal to distance by time. Okay. Now, we see over here that speed and time are inversely proportional to each other. That means if speed increases, then to cover up a particular distance, time decreases. Okay. And if speed is decreased, then to cover up the same distance, time will be increased. Okay. Or we can say if speed is doubled, the time will be halved. If speed is half, time will be doubled. Okay. Similarly, speed is directly proportional to distance. Now, if distance increases, and we have the one particular time, that definitely we have to increase the speed. Okay. Similarly, if distance is decreased and we have that particular time only, then we need to then we can decrease the speed in fact. Okay. So precisely, speed is directly proportional to distance when time is constant, and speed is inversely proportional to time when distance is constant. In this case, with the jogger, he's covering half the distance and double the time. Now, if distance is halved and time is doubled, definitely the speed will be 1/4. Okay, isn't it? Now let's do it by calculation also. Suppose this is the speed of the cyclist, S1. Now we calculate the speed of this particular person who is jogging. So it's S2. Okay. Now distance is halved. So it's d by 2. And time is doubled. So it is 2 t. Okay, now let's calculate the ratio of S2 by S1 since we have to calculate the speed of jogger to cyclist. So it is S2 by S1. It's d by 4t by d by t. So it is 1 by 4. Okay. And friends, you can do this problem mentally if you are conceptually clear about the proportionality of speed, distance, and time. Okay. So I hope you are getting my point. Now, friends, let's say this question. A car can finish a journey in 10 hours at 48 km per hour. To cover the same distance in 8 hours, the speed must be increased by. Friends, we have already discussed that speed is inversely proportional to time if distance is constant. Okay, that means if speed is increased, time will decrease to cover up the same distance. Okay, and if speed is decreased, time will increase to cover up the same distance. So we can say st is equal to d. Okay, in this case the distance is same. Okay, but time and speed are changed. So what we can say, s1 t1, that is first speed into first time, is equal to second speed into second time, since in both the cases distance is same. Okay, so a car can finish a journey in 10 hours at 48 km per hour. So it's s1 is 48, t1 is 10, S2 we have to find out, and T2 is 8. So S2 must be 60. That means the new speed must be 60 km per hour. Already he is having the speed of 48 km per hour and the new speed is 60. So he should increase, it should increase, the car should increase the speed by 12 km per hour. Okay. Now let's say this interesting question. While walking 3/4 of the normal speed, Ram arrives 1 hour late. What is the normal time? That means what is the normal time to cover up that particular distance? Okay. So, friends, further the same logic is over here. Speed is inversely proportional to time. That means speed is distance by time. If distance is constant, if and speed is increased, time will be decreased. Okay. Now let's understand this concept. Let's say we have to cover up this distance, that is A, B. It's any distance, maybe 100 meter. Okay. Now if this distance is fixed, okay. Now this person, maybe Ram, if we talk about, if he doubles his speed, he'll be covering this distance in half the time. Okay, isn't it? If he doubles his speed, he will be taking half of the normal time to cover up this distance. And if he's doing his speed 3 times, then he'll be taking 1/3 of the normal time, isn't it? Similarly, if he make his speed half of the normal, then he'll be taking double the time. And if he does speed 1/3 of the normal, then he'll be taking 3 times of the normal time. Now we assume that the normal time is 1. Okay. So if he's walking with 3/4 of his normal speed, his time will be 4/3 of the normal, isn't it? So 4/3 is what? 1 plus 1/3. We are doing this calculation in terms of fraction only. So just listen to me very carefully. It's a very simple concept. If he's doing his speed 3/4 of the normal, then he'll be taking 4/3 of the normal time. That is the reverse of this, since speed is inversely proportional to time. That means he's taking 1/3 part extra from the normal. Now here in this case, he is getting late by 1 hour, and this 1 hour is equivalent to 1/3. So 1/3 is equivalent to 1 hour. 1 hour. That means 1 is equivalent to 3 hours. Now what was 1? That was a normal time which he is taking to cover up that particular distance. So actually he regularly takes 3 hours to cover up that particular distance. Okay. And on that particular day, while he made his speed 3/4 of the normal, he's taking 1 hour more. That is, he's taking 4 hours to complete that particular distance. I hope you are clear. Let's see this case. While walking at 6 by 5 times his normal speed, a person reaches his destination 20 minutes early. What is his normal time? Friends, in the previous case, the person was reducing his speed. In this case, the person is increasing his speed. Now, further, speed is inversely proportional to time. So, if he is making his speed 6 by 5 times the normal, that means he'll be taking the time as 5 by 6 of the normal. Let's see, the normal time is 1, that is a unit. So, he'll be taking 5 by 6 of that. Okay, 5 by 6 of 1. That means he'll be taking 1 by 6 less from normal. Now this 1 by 6 is what? In this case it is 20 minutes, isn't it? Since he's taking 1 by 6 part less than the normal and he's getting 20 minutes early to his destination. That means this 1 by 6 is 20. So if 1 by 6 is equivalent to 20, 1 must be equivalent to 120. And 1 was his normal time. Okay, so his normal time is 120 minutes, that is 2 hours. So friends, if you are conceptually clear about the relationship of speed and time, then you can do this sort of problems even mentally. Just listen to me very carefully. How do you visualize the situation? Since he is making his speed 6 by 5, the time will be 5 by 6, which is 1 by 6 less than the normal, and that 1 by 6 is this 20 minutes. So 1 is 120 minutes. Okay, that is 2 hours. I'm sure you are clear. Let's take the next problem. Now let's do this question. Walking 4/5 of my usual speed, I missed the bus by 5 minutes. What is my usual time? Further, friends, will not be going for any sort of paperwork. Just listen to me carefully, and I hope, and in fact, I expect you should do this problem and then match your solution and final answer with mine. Okay, so if I'm making my speed 4/5 of the usual, that means my time to cover up that particular distance is 5 by 4. Not what now what 5 by 4 is? It is 1 by 4 extra than 1. Now that 1 by 4 is extra, and that extra is 5 minutes. So 1 by 4 is 5 minutes, that means 1 is 20 minutes. Now 20 minutes is the usual time which I am taking to cover up that particular distance. Okay. So I hope your answer and solution is matching with mine, and you are conceptually clear about this relationship of speed and time. Now try this question, and don't touch your paper and pen, just do it mentally. Walking at 3/4 of the normal speed, a man is late by 2.5 hours. That means 2.5 hours. What is the usual time? Okay, now if the speed is 3/4, the time will be 4 by 3, that is 1 by 3 extra. Now that 1 by 3 extra is 2.5, that means 1 is 7.5 hours. Okay, so the usual time is 7.5 hours. Now let's take this question. If a boy walks from his house at 4 km per hour, he reaches school 10 minutes early. If he walks at 3 km per hour, he reaches 10 minutes late. What is the distance from his house to school? Friends, very simple and interesting question. If you are clear with the concept, this sort of problems can be done in just 20 to 30 seconds and even without paperwork. Okay, so just listen to me carefully. This is suppose his house and this is suppose his school. Okay, friends, there are two timings. In one case he is reaching 10 minutes early, and in other case he is reaching 10 minutes late. Okay, suppose it is normal time, then here it is plus 10 and here it is minus 10. Then what is the difference between these two is 20 minutes. That means the mutual difference between these two timings is 20 minutes, or we can say 20 by 60 hours. Okay, now let's assume the distance between house and school is x. Okay. Now, if x distance he is covering with 4 kilometer per hour, what is the time he will take? That is x by 4. Okay. And if he is walking this particular distance at 3 kilometer per hour, then he will take x by 3 hours. Okay. And the difference between these two timing is this, isn't it? So let's calculate it. It's 4x minus 3x, that is x by 12 is 1 by 3. So x is equal to 12 by 3, that is 4 kilometer. Okay, as simple as that. So as I told you, you can do this problem even mentally without paperwork and less than 30 seconds if you are clear about the concept. Okay, let's take one more problem like this. Now friends, you try this question and then match your solution and final answer with mine. By walking at the rate of 4 km per hour, I reach my destination 15 minutes too late, and I reach my destination 10 minutes too soon by walking at 6 km per hour. Okay, so how far I have to walk? So suppose this is the distance which I have to cover up, and the mutual difference between the timing is it is 15 minutes late and it is 10 minutes early. That means the mutual difference is 25 minutes. That means we can say 25 by 60 hours. Okay, now let's assume the distance to be x. If I'm walking at 4 km per hour, I'll be taking x by 4 hours. If I'm walking at 6 km per hour, then I'll be taking x by 6 hours. Okay, and the difference between them is 5 by 12 hours. Okay, now just calculate it. Either you take LCM or just cross multiply, doesn't matter. So it is 6x minus 4x, that is 2x by 24, or we can say x by 12 is 5 by 12. So if x by 12 is 5 by 12, x is 5. Isn't it so simple? So I'm sure your answer is also matching with mine. Now friends, if a train runs at 40 km per hour, it is late by 11 minutes. But if it runs at 50 km per hour, it is late by 5 minutes. The correct time to complete the journey is. Now, friends, quite similar problem to the previous ones. And here I'm not going to draw any sort of line and diagram over here. So just try to do this problem mentally. Okay, what is the mutual difference between the timing is? It's late by 11 minutes and it is late by 5 minutes. So in both the cases, it's late. Okay, but the mutual difference is 6 minutes, or we can say 6 minutes. That is 6 by 60 hours. Okay, so it's 1 by 10 hours. Okay, now let's assume the distance to be covered up is x. Now if it runs at 40 km per hour, it will be taking x by 40 timings, and if it is running at 50 km per hour, then it will be taking x by 50 hours. Okay, so it is 50 minus 40, that is 10x by 40 into 50 is 1 by 10. So x is 20 km. That means the distance which has to be covered up is 20 km. Okay, but we are asked the time to complete the journey, the regular time or the normal time to complete the journey. Now suppose the total distance to be covered up is 20 km and the person runs at 40 km per hour. Okay, so the time he will take is 20 by 40. That means he'll be taking half hour, or we can say 30 minutes. But when he is walking at this speed, he is getting late by 11 minutes. That means in this case, he is taking 30 minutes. That means his regular timing is 19 minutes. I hope you are getting my point. Okay. Friends, I hope you might have enjoyed the session, and you must be getting the comfort with time, speed and distance. We'll be taking some more problems, some more applications of the topic in our next sessions. Till then, do revise this session and the first session of time, speed, and distance. So you'll feel better in the next class. Okay, bye bye.